Hello, welcome to another episode of Easy Artificial Intelligence R.A.G. I really like this example. We're going to see how to do a similarity search and then also how to use memory. So example of memory is, let's say it's a chatbot. The user's asking, how do I assemble product 1, 2, 3, 4? And then the AI answers. Then the user asks, when do I put on the top? TOP question mark. So, I mean, basically, maybe not the greatest example, but the bot has to remember the sequence of questions so that when it asks a second question, it's going to know what it's talking about. So, in this example, we've got PDFs that are loaded into a Chroma database. So this is a diverse set of PDFs. If we look here, here's the folder we're going to be using. Data file 2 input PDF 006. And we start with this environment variables here, listing all the variables we're going to be using in our run. So anyway, if we look at this folder, data files input PDF 006, we see a bunch of PDF documents. They're intentionally not related to each other. So we're going to read everything from the directory, split into chunks and vectorize them, store in a Chroma database, load all the vectors from the database, and for a specific question, we're going to vectorize the question and then get similar documents. So Langchain is the framework we're using. I could do another video at some point about what convenience we gain from using Langchain, but it is quite a convenient tool to use with large language models. So we're going to be able to ask questions using the loaded documents, which are these documents in this folder. And we do have memory. So we have PDFs, parsing, loading into database, similarity, memory. Here's a reference, R.A.G remembering chat history, which obviously you're going to need to know chat history so that the bot will need chat history. And here's a section on memory-based conversation. There's a reference. So that's basically it. You're going to want to be running this in your own environment. If you're not sure what that is, you can look up VENV or Conda to come up with a custom environment. All right, so with that, we're ready to get started here. So we'll load up we've got this ENV secure, which I've gone over before, is where I load my API key. And then the .env R.A.G 0006, where I have all my runtime variables. Set logging. So in this case, we've got like this Chroma 2 output. This is where our Chroma database goes. What we're going to do is we're going to just delete the data of the various output directories for starting from scratch. Okay. Here's a function to get a query, turn all lines in a query file that we feed in. So in this case, we'd have data file. There'll be some data file 2 input 006, and then data file 2, let's see the name of the file, data file 2 input query. All right, so we're going to be beeping. Let's move the phone. Data file 2 input query 006. Here we go. So there is a list of questions, random questions, related to various documents. So now we got that done. In case there's an exception, stop execution. Okay, check function to check the files. All right, so here we're getting started with the PDFs. So we get a list of the PDF documents. So that's good. That's a list and the number of PDF documents we've got in there. And then this, we got this PDF page chunks. PDF loaders, which is we import this library PyPDF loader to basically load the PDF, to load the PDF files into Langchain documents. So this is a basic syntax you can use if you're starting with multiple PDF files. Text splitter, again, recursive text splitter. So we're going to define a chunk size and an overlap, and then we end up with 2,809 data chunks. Embedding. So here's where we define our chroma DB, vector DB, and we're going to create it from using this Langchain from documents. So documents equals splits. The splits are up here from the text splitter. Embedding equals the embedding we define. Persist directory from the persist directory would be this chroma 2 output. And IDs equals a numeric ID that's going to be increasing by 1 for each item. So this shows the number of stored entries, 2809. Okay. This, you could read about this here. Basically, when you're using a similarity score, there was a little bit of an issue, which I'm indicating here. Basically, you get back a list of tuples instead of a list of document types. So this was a fix to create this class, which returns parsed documents. So here, we get a list of all questions. This is indicating the type is list of tuples. The class is list. So we've got a list. The docs is a list, and each individual item is a tuple, which is the format it is expecting. You could, without really exactly figuring the whole thing out and dissecting the whole thing line by line, you can use this. I've got the reference here. You could use this if you're using the score docs. So similarity search with score. So it works different if you're using similarity search versus similarity search with score. So here we're going to load the vector database that was persisted earlier and check, we'll get the count 2809, that's correct. So basically we have loaded all of our chunks into a vector database, and then we persist it, and then we load from that database again, and we get the correct count. Okay, question. All questions. So we've got a document. Basically what we're printing here is the similar items. So we're taking the first question and we're getting a score similar item list. So we're getting the similar items to the first questions. If we look at this specified query, we can see the first question. What fueled strong inflation pressures in Africa economies in 2022? Of Central America. So this is giving you the entire page content. So here, if we scroll down, of Central, you can see that the documents, I mean, you can read through this and just basically see the documents it's suggesting are the similar ones. So that has worked. We picked out the first question, boom. And we did a similarity search with score, similar items, and we came out with a list of similar items, and then we're printing out the list of similar items. Beautiful, okay. Function, we feed in a question and a search type. Okay, and this is, we're going to loop. So, you have MMR or similarity search. You can look at those. They're fairly similar. We've got a loop max, which I've got set to 2, just to prevent any endless looping. Okay, so we'll do this. This takes a little bit of time. So basically where we are here is we've got a directory full of PDF files. We load in every file in that directory. We basically split the files up into chunks, load the files into a vector database, load the vector database, do a similarity search based on questions, pull out the applicable documents. Okay, and this we should be finishing up here. Okay, what fuels strong inflation pressures in Africa economies in 2022? Search type. So this we could compare the search types. You can see they're basically identical in this case. The answer, what fuels strong inflation pressures in Africa economies in 2022? The strong inflation pressures in Africa in 2022 were fueled by higher food prices and effects of Russia's invasion of Ukraine. So this is good data that it wouldn't have had before loading the LLM, and these are all specific. These questions are all specific to our list of PDF documents, which if we go back, we will have PDF. Here we go. So there's a list. So you can change the questions by going in here. Any question you put in here, it will answer, and you will know what questions to put in by reading documents. I'm not sure why that, it's not letting me open the PDF documents in there, but anyway, you need a PDF reader, but that, you could look through the documents, ask any questions you want, and double check the results. The results should be spot on. Okay, we don't need that. Okay. Okay, so we've done that. That's all working good. Now what we want to do next is we want to use this history. So this, you could see, where was the first reported record of the Atlantic soft pout? This is context from one of the documents. And then how was the specimen caught? What waters does it inhabit? I'm just hard coding the questions in here, but you could modify this also to read from the input questions document. So if I do this, it's going to take a bit. Question: where was the first recorded of Atlantic soft pout? And then you've also see the chat history, so we can scroll over. As we go through, the chat history will be populated, and then it's got the answer. The first reported record of Atlantic soft pout was in the Eastern Meridian Sea. So basically, you could reformat this if you wanted to, but okay, the output is correct. How was a specimen caught? So it's not going to know here unless it has the chat history, which it has here. So you can see this is actually kind of neat doing the full dump, because you can see exactly what it's saving as far as the history. So when it asks the second question, it's feeding in the history from the first question. It's really a nice framework. So result, the specimen of Atlantic soft pout was caught. So it knows what we're talking about. Where was the first reported record of the Atlantic soft pout? That's in the history. What waters does it inhabit? Oh, what waters does it inhabit is down here. All right, so you can play with that. This is basically giving you the similarity search and the history along with the R.A.G. Thanks for tuning in. Again, thanks for the comments and the like and subscribes. Talk to you later.